Hi, I'm Alan Hirahara, here to talk about DX reinforcement matrix. The DX reinforcement matrix is an ECM patch. We've found that rotator cuff repairs without ECM patches have a failure rate as high as 20 to 57%. In vivo animal studies have actually supported the use of acellular dermal grafts for augmentation, and biomechanical studies have shown dermal grafts to have a superior suture retention over SIS or basement membrane patches. Several acellular grafts, however, still contain significant DNA, which gives us significant complications. The perfect graft has to be able to withstand expected anatomic forces, tensile and suture, has to be non-reactive, and has to be present throughout the process while the tendon is healing in the repair. Has to be easy to store, prepare, and use. Now, how do we get there? There are several different types of grafts out there. Some come from allograft, some come from xenograft. The tissue type matters, whether it's dermal, SIS, or BM. The processing methods also matter, which usually gives us strength characteristics, reactivity, inflammatory response, degradation, encapsulation, or integration issues. Also, sterility and aseptic technique matters. The patch processing method is a critical part of the actual process to get the proper patch. Different types of processing gives us different types of characteristics. For example, the DX reinforcement matrix is decellularized. It revascularizes and repopulates quite well and eliminates or reduces inflammatory response. What the DX reinforcement matrix doesn't do is it doesn't denature the matrix, which can lead to inflammatory response, and it doesn't intentionally cross-link, which could inhibit incorporation and result in encapsulation. And as you see, there are different kinds of patches available. The DX reinforcement matrix is a porcine patch, but doesn't have cross-linking as mentioned, and uses E-beam for irradiation, and is easily prehydrated. The peer-reviewed clinical studies, however, do not support SIS grafts as they've been abandoned as they showed high failure rates. Dermal grafts, however, show excellent potential. Intercalary placement, bridging, is something that is currently not being done because biomechanical studies do show equivalent load to failure in mechanical properties, but few actually show any clinical success. At this point, the complication rates are usually related to the processing, in that we see about a 20% aseptic reaction rate, and we have several types of devices that have shown high cellular infiltration and chronic inflammation. A lot of this is usually related to the retention of DNA, as mentioned before. So even though Graft Jacket has a high tensile strength and load to failure, it contains a fair amount of DNA, which a DX matrix does not. Next, we'll show you techniques of how to incorporate the patch into your cuff repairs.